Okay, good. So I am going to talk about basic batch and Slurm, and this is going to be a very simple introduction to batch and Slurm. I will talk about more advanced stuff for this tomorrow, but I will talk a little bit about it today, about which commands are there and such things. So, what is a batch job? What are some important commands regarding batch jobs? And how do I make a batch job? So we will have an introduction to the Slurm scheduler commands. We will look at the structure of a batch script, and there will be an example to try. And just a reminder here, I have put these project IDs, and you should all be in a course project, so you can see here which one it is you're using, depending on which system you are using. There's also storage space, as you have been told before, and this is shown here. If you are on Cosmos from Lunark, there isn't one, but there is a lot more space in the home directory, so you should be able to just use that. So just create a directory there, and otherwise follow what was said earlier today. There's also a reservation on HPC2N and Lunark, but not on any of the others. And the one on Lunark is only for Friday, so this is not very important. Another thing is that the ones on HPC2N are magnetic. That means they will be used automatically, so you don't need to do anything. However, Kebnekaise has some luster problems right now, so you may or may not be able to use it. But I am logged in here on Dardel. And I should perhaps say that I'm going to go to this directory here. I will do that immediately. Here. And here I have created a directory for myself using my username, because that's an easy way to get a unique one. And I have also put the exercises there, and I'm going to check why there are so many. Okay, this is the one you should use, exercises tar gset, if you are copying it from there. Otherwise, you can just download it with wget. I'm going to go to my directory, and I am going to copy it here, download it with wget, just like earlier was shown. And it seems GitHub is a bit slow, but it fetched it. So that's good. We have it here. Okay, so what is a batch job? Batch systems are used to keep track of available system resources, and they also take care of scheduling jobs of multiple users that are running tasks simultaneously. It organizes submitted jobs to some sort of queue that will be at each of the system. And there is also some policies to enforce. It enforces the policies that are on this queue here for the system resources. And that is different between the different centers, but there is a job scheduling policy each place. And it's usually something like, depending on the priority of your project, how much allocation you have, how much you have used, and in many cases also the order you are submitting your jobs in, and so on. But it differs between centers, and you can usually find it on each center. They will have it written there. Most or maybe all Swedish HPC clusters are using Slurm. Slurm is an open source job scheduler, and it has three key functions. It allocates to users exclusive or non-exclusive access to resources. for some period of time, so it finds slots that are available. It provides framework for starting, executing, and monitoring work on some allocated nodes, that is the cluster. And third, it also manages a queue of pending jobs in order to distribute the work across resources according to that center's policies. And it's designed to handle thousands of nodes in a single cluster. And it can actually handle a throughput of 120,000 jobs per hour. So, what's a cluster? Well, you know, I'm guessing, but a cluster is, for instance, a Dardel or a Tetralit, one of these compute clusters. And there is information about the various clusters hardware on this link here. There are many different clusters right now, and it's all listed there. And in not so long, we will have Arrhenius instead of Alvis, Dardel, and Tetralit, which will then probably become local systems, as Björn mentioned. And this is a brief overview of what is on the current systems. And there is also an overview of what is going to be on Arrhenius, as far as we know. It should be open in a few months or so. So very short, a cluster is comprised of login nodes, which is what you go to when you log into a system. And then there is some calculation or compute nodes that the jobs are running on. And this network of computers, the computers are each considered a node in this cluster. So a node is a computer, and each node has several processor cores and RAM. And there's usually a local disk called Scratch as well, where the jobs are running on. And in many cases, also GPUs and things like this. So think of it as a whole bunch of computers that are put together. And that's basically a compute cluster. So the user logs into login nodes to the internet through something like SSH or ThinLink or these on-demand portals that we will talk about later. And on the login nodes, you can do some file management and you can do lighter data analysis. You should not use it for intense computing. That is for the calculation nodes. Anything longer, resource intensive, or parallel jobs must be run as a batch job or interactive sessions. Otherwise, you will clog up the login node, it will become slow, unusable, and everyone will be unhappy. And the sysadmins will go ahead and kill your job. So no one wants that. So don't run anything heavy on the login nodes. There will be a NAISS course about running jobs, and there is a link to the material here. It will run in early June, together with the NAISS intro days again, and again in the fall. So some good commands for the batch system. Slurm, as the batch system is called. The most important one is to submit your job. You say sbatch and then the name of your job script. The job script, you can name it completely as you want to. And just to have something to use as example, I'm now going to go ahead and uncompress this tarball. I'm going to go into it and to day 2. And then I will go to PDC. And in here, you can see there are some example scripts. And I will talk more about them in a moment. Right now, I'm just going to make one of them ready to run, so I can show you what happens when I give these commands here. There are things that needs to be changed in them. More specifically, you need to add whatever the name was you gave your directory here. So just put your name of the directory here. There will be a similar one on the other centers. Just why is that? Should it be like this? I'm simply creating a path because I have the programs in another directory. The project ID here is the correct one, so you don't need to do anything to that. So what I will do is I will show you that I am submitting this job. And what it does is not important right now. I just want to show you what happens when you submit something. And maybe I should put it up here further so you can easily see it. So I submit it with SBatch and my job. And then I get this line here, submitted batch job, and then a job ID. This job ID is important because if there's problems with the job, you could give this to the sysops because they will then be able to go in and look at the job. It's usually useful to have this job ID here. You can also use it to see some more information about the job. So you get the job ID when you submit it, but if it's still in the queue, you also get it by saying SQ and then minus me. Then it shows all the jobs you have in queue. This is not in a queue anymore because it already started running. But see, if I just say SQ, I get everyone's jobs, and there's a lot of them. But I'm going to go ahead and submit this job a few times, like that. And then you can see here that they are now shown here in a queue, what jobs you have. So there are the job IDs. The petition is shared. There are various petitions at this DARDL here, TPU petition, shared petition, and so on. The job has a name. You can set it. If you don't, it will be named your batch job. Then it shows the user, which here, of course, is you, because you asked to only see the ones for you. Then there's a status. The status can be various things, but here it is pending for some of the jobs. That means they are waiting for resources to be allocated. Another one here has R for status, which is running. And then there are some that has CG, which is short for completing. And then it also shows how long the job has been running. As you can see, it's a very short job. The running one here is at 3 seconds, completing ones at 4 seconds, and so on. And then it tells you how many nodes, or more correctly, this is how many cores it's running on. And what is the nodes it has been assigned? Or if it's not running yet, if it hasn't even started, then it could have priority, which means that it's still pending, waiting for a slot. And the reason it hasn't gotten one is that it does not yet have a high enough priority. So this shows some of the things you can get here. You can also give the Slurm commands on a command line instead of in a batch script. That is not recommended if it's more than something short for testing, because if you put it in a job script, then you keep the commands. You can later go back and see what it was you said so that you can run things the same way or something like that. You can also check on a specific job with the command scontrol show job and then the job ID. To do that, you would say scontrol show job and then, for instance, this job ID here. And it's valid while it's running, while it's pending, and a short time afterwards. And here you can see there is a lot of information. There's the job ID, there's the user ID, job state is currently completed. It tells you how long did it run, how long was it allowed to run, which was 5 minutes, but it only ran 2 seconds. It tells me when was it submitted, how long, when did it start, as you can see here, and things like this, when did it end, and which partition did it run in, what nodes it had. There are many, many useful informations here. And if it ran on GPUs, it would say here it says that it ran on CPUs and what memory it used and such. And it also tells us the batch script, what is the path to it and the name of it, and so on, and where the working job was, where you, if it was, for instance, looking for data or something. So everything is here. So very useful. You can also delete a specific job with S-cancel and then the job ID if it's still sitting in the queue pending. Maybe you found out that there was an error and you don't want it to run because, well, it's not going to give you data anyway. You don't want to use the allocation if you're not getting anything out of it. You can delete all the jobs that are pending with S-cancel -u and your username. As mentioned before, submit job S-batch, the job script. You can get info on partition and nodes with S-info, like this here. There is a lot of different partitions on Dardel. There's a shared one, the main one, and GPU one, and so on. And they are mainly important for the GPU ones where you have to use it. So I think you actually have to use it always on Dardel, which is a difference to most of the other systems where you don't have to always use the partition. Okay, so now we know something about the commands for the batch system, some of the more important ones. And let's now look at batch scripts. As you know, that is needed for a batch job unless you do it interactively. It's not interactively automatically, and we will talk about interactive jobs later. That is not interactive means you cannot change anything to the job while it's running, but that can also be an advantage. You just prepare everything, submit it, and then it sits maybe for days and runs your data while you can do other things. So let's look at the Slurm submit file, which is also called a batch submit file, batch script, or job script. So you will see all these words used if you Google it. We have some guides and documentation at various places on these centers here. So the workflow, you would write a batch script. You put any modules you need, any prerequisites, packages, and maybe you are loading a isolated or virtual environment, as mentioned earlier, that you could have created. And then you also ask for resources. If you need GPUs, if it's a parallel job, serial job, so on and so forth. And if you have a Python script, you give some commands to it. And then finally, you submit it with sbatch and whatever you called it. You can call it what you want, as I said. It's common to put file extensions like .sh or .batch, but you don't need to. Choose any name that makes sense to you. So let's go ahead here. And here is just a quick walkthrough of how you get hold of the exercises. I'm guessing you did this here. wget and the exercises, and then untard them. I can show it here also. And they are then in exercises. Day 2 programs, the Python script, and the batch scripts will be in exercises, day 2, and your center. And I would suggest to do what I did, to simply go and make the changes, to just add your username. Let's try and open, for instance. You can use Nano. That is probably the simplest editor if you're not used to VI or Vim. And Nano is a module maybe on Dardel. Nano is a module on Dardel, so you need to do module load and Nano before you can use it. So this is the batch script for sum of 2 arguments. In this example here, I'm using the one that is matrix-matrix multiplication. Most of it is the same. You're just loading some module. This is simply a simple way of showing you what you need. So maybe I should just open that one. I will do that. So module load nano, if you want to use nano. And then let's open this one here. And first we have a line that is hashtag exclamation mark /bin/bash. So called a shebang. This is something you can ignore, but just make sure it's there. It's telling the batch system that this batch job will run in the bash shell. There are shells on Linux. It doesn't matter. It's just that if you want everything to be compatible with the batch system, you put that line there, so that it knows how to interpret commands correctly. Then another line that has to be there, that is the allocation, the course project. Every batch command to the batch system starts with hashtag and then sbatch in capital letters. So it has to be capital letters. It has to have a hashtag in front of it. If you want to uncomment it, you can put an extra hashtag there. So these 4 here are all commands to the batch system. First, I say I want to run in this project. That is the course project on Dardel. Then I say how much time am I going to use for this job? And I'm going to make an estimate. It takes 10 minutes. It actually probably takes more. So I'm going to change this to 25 minutes because I have upped the size of the matrices. Then and this is hours, at most a week, minutes, and then seconds. So now I'm asking for 25 minutes and I'm going to change it here. You can see I have a hashtag here after. This is a comment. You can also make comments like this here. And now I'm asking for resources. I'm asking for 1 core. And I'm telling it I'm running in the shared partition. This is enough to give me a core for 25 minutes in this allocation on this partition on Dardel. There are minor differences. You can go in and look at them here for your system. You see that most of these don't ask for a partition. In fact, only PDC does. And this, if you want to look at the very small matrix multiplication Python script. So, but we have this here. Then, since I didn't want to clutter up the directory with the programs, I went ahead and put all the programs into a directory called programs. And since it's a different one, I could either preface my script with all this here, or I could make a variable, which I choose to do, and then set it and tell it that this is the place I have my programs. And I need to make a change here where it says my dear, because I need to tell it that it's in my directory. So this is the path to where the programs are located. That is the only thing this does here. It sets an environment variable, my path, that points to the directory of the programs. Then I load some modules. I need only the Cray Python module on Dardel because it has what I need for this here. And then I run my Python script with Python, and in this directory pointed to by my path variable, you put a $sign in front of a variable to get the content of it. And then it's called mmmult.py. So I save this with Control, hold down, and push X. Then it asks me, do we want to save the modified buffer? Yes. It suggests to use the same name as I had before, and I'm just going to accept that with enter. I could otherwise change it. If I had just opened nano with an empty file, you would have had to give it a name here. So we do like this. So now we have this one here. It's a very long line. I'm sorry about that. So you can go ahead and do this, and when you have done that, then try submit it with sbatch, like I do here. And then you can maybe do it twice or something, so you have something to look at. And then you can do sq minus minus me, and then you will see what happens to it. And it's already completing. That is not a good sign. I'm thinking that I made a error, so it's not finding it. But I need to change that to look at that later. But you can run the sum2 args, and actually that is you can also try and create it from making changes to this script here. So take the script for your center and then try and make changes so it instead runs this if you want to. Or if you want something simple, just run it after putting in your username. So here, put in your username at the place where it says my dear, or it's set. And that is the only thing you need to do here. I simply want you to see a batch script and try and submit it and try do SQ and things to see that you have it in your queue. And that should take only a few minutes. So do that. And then at 12:05, we should take lunch. And then let's be back at 13:05. So you get a full hour for lunch.